This is Algebra 2, Lesson 15. We're going to talk about elimination, and we're starting on page 79. The addition rule for equations tells us that the same quantity can be added to both sides of an equation without changing the solution to the equation. So if we have x plus 2 equals 7, we can subtract 2 to both sides and get x equals 5. Since we subtracted 2 from both sides, we didn't change the value of the equation. The multiplication rule says we can multiply or divide the same number by every term of an equation without changing the solution to the equation. So we can solve this by first distributing, and we'll have 2x plus 4. 2x plus 4 equals 14. And now we can subtract 4 using the addition rule. And we've got 2x equals 10. And now using the multiplication division rule, we can divide both sides by 2. And x equals 5. We're going to use a combination of these methods to solve series of linear equations by elimination. Use elimination to solve. Our series is 2x plus y equals 11. And 3x minus 2y equals 6. Now you remember when we're doing elimination, that means we're going to add the equations together so that we only have one equation with x's and y's so we can solve them. And we want to add them together in such a way that one of the variables is canceled out. So we're only left with one at a time to solve. In order for one of these variables to cancel out, one of them needs to be the inverse of the other. So we need 2x and negative 2x, or y and negative y, or 3x and negative 3x, or negative 2y and positive 2y. So the coefficient of the variables needs to be the opposite of each other. Right now we have 2x and 3x, and added together that's just going to give us 5x. That's not helpful. We have y and negative 2y, and added together that's going to be negative y, which is also not helpful. But if we multiply this top equation by 2, when we add them together, this will be 2y, and this will be negative 2y. So the y's will cancel, and we'll be able to solve for x. Okay? So we are going to multiply every term in the top equation by 2, so that this middle one is 2y. We have to multiply every term in the equation by 2 so we don't change the value of the equation. So 2x plus y equals 11, and every term times 2. Okay? So that's 4x plus 2y equals 22. And now we can add that to this equation. 3x minus 2y equals 6. We add the equations together, and we get 7x, these cancel, equals 28. Okay, now we can solve for x by dividing both sides by the coefficient 7, and x equals 4. And now we can solve for y by plugging x equals 4 into both of these equations, and we should come out with the same value of 4 if we did everything, the same value of y if we did everything correctly. So we have 2 times 4 plus y equals 11, and 3 times 4, because x equals 4, minus 2y equals 6. 8 plus y equals 11. Subtract 8 from both sides, and y equals 3. 12 minus 2y equals 6. Subtract 12 from both sides. Negative 2y equals negative 6. Divide by negative 2. And y equals, our negatives cancel, and we're left with 3. Y equals 3. So the ordered pair that makes the point where these two equations cross, if we graphed them, is x equals 4 and y equals 3. Okay? Let's try another one. Use elimination to solve. 3x plus 2y equals 23, and negative 2x plus 3y equals 2. Okay. Both sets of coefficients have, both sets of variables have coefficients. So we need to find the least common multiple for one of them. This one already is positive and negative, so it will be easy to make these two cancel without having to also multiply one of them by a negative. So let's work on canceling the x's first. The least common multiple of 3 and 2 is 6. So we're going to multiply the top equation by 2 so that this will be 6x. We're going to multiply the bottom equation by 3. And remember, we need to multiply every term so that this will be negative 6x. Okay, so using the distributive property, we have 6x plus 4y equals 46. And we have negative 6x, that's an x, not a v, plus 9y equals 6. And now we can add these together. The x's cancel, and we're left with 13y equals 52. Divide by 13 on both sides, and y equals 4. Okay, now we're going to plug this into both of our original equations and solve for x. So we have 3x plus 2 times 4 equals 23, and negative 2x plus 3 times 4 equals 2. 3x plus 11 equals 23. Subtract 11. 2 times 4 is not 11, it's an 8. I don't know where that 11 came from. Sorry. I think I was subtracting already. Alright, 3x plus 8 equals 23. Subtract each side by 8, and we get 3x equals, it's 15. I have no idea where I got the 11 from. Divide both sides by 3, and x equals 5. Okay, on this side we have negative 2x plus 12 equals 2. Subtract 12 from both sides. And negative 2x equals negative 10. Divide both sides by negative 2. And x equals 5. Good, so the ordered pair where the graph of these two lines would cross is x equals 5 and y equals 4. And that's it. That's it for this lesson. Try your practice problems, do your homework, let me know if you have any questions. Thank you.